Okay, so let's have a quick look here at the kinematics test. True, false, true. Obviously, you know the correct answer when the multiple choice goes CCAB. CCAB.
No.
Because actually, I didn't realize there were this many multiple choice questions on here. AAC. AAC. 8, 9, and 10 is AAC. Zach, can you put the chart up for me? Then we get to number 11, BB, DD, EE.
E.
BB, DD, EE.
Why did you do that?
Didn't do it on purpose. Name 3 parts to a car that can change its velocity: the gas pedal, the accelerator, the brake pedal. By the way, it's BRAKE.
I got that.
And the steering wheel,
Why the steering wheel?
because you can change the direction.
All right.
Okay, so let's go to the problems. You don't want to. Number 18. Actually, number 18 was fairly well done. A car is traveling along a highway with a speed of 23.6 meters per second. When the driver sees an obstruction 198 meters directly ahead, it takes the driver 0.54 seconds to react and begin braking. How far does the car travel before it begins to slow down? So what we've got here is we've got 2 parts to the problem, right? There's the reaction time part, which is this time right here, right? This distance here happens in 0.54 seconds. And the speed over that time remains 23.6. This is the slowing down portion. Okay, so there's 2 parts to the distance. So how far does the car travel before it begins to slow down? So because it's traveling at a constant velocity, V bar equals D over T. So we've got 23.6 is equal to what displacement over 0.54 seconds? And you get a displacement of, somebody help me out, 12 point something? 12.74 meters. Okay? So it travels 12.74 meters in the reaction time phase. Part B asks, how long will it take the car to stop once the brakes are applied, provided the car stops just before the obstruction? So the first thing you need to do is figure out what this distance here is. And that's fairly obvious. D2 is going to be the 198 minus 12.74. Right? Which is 185.26.
Is that worth the mark?
That is worth a mark.
Yeah, I got that on the top of my page.
We need to talk about organization in a bit, Troy. Okay, now what you can do here is you can say that the average velocity is equal to VI plus VF over 2. The initial velocity is your 23.6. Your final velocity is 0. In other words, find your average. That's going to be 11.8 meters per second. And then you're going to go V bar is equal to D over T. 11.8 is equal to D over, now that D there is our 185.26. Solve for time. No, not, yeah, we're solving for time? Yeah, 15.7 seconds. Okay, so that's part B. Did I write so quick? Good for you.
G. Is that 105?
It's the same number as this, Troy. Yeah, there's more than one way to do it. C asks for the acceleration, right? Does it not? Yeah. A equals delta V over delta T. The change in the velocity is minus 23.6. The time is what we just figured out, 15.7. And you get a time of, sorry, a deceleration of minus 1.5 meters per second squared. What I would consider a fairly easy warm-up kind of problem.
Yeah. Next question.
What is your question?
This is one more question.
Okay, now the second one, we all knew this was going to be on the test, didn't we? This is a Jack catching the bus or a Fred and Barney kind of question with a little twist. A truck travels at a constant speed of 29 meters per second in the fast lane of a two-lane highway. So I've got the truck. Here's what I'm going to do, just to make it a little more exciting. And so I don't have to draw a truck. Oh,
That's bad.
I want a truck. What do you like? This one?
Yes.
I'll make it smaller.
No, I want to get a pickup truck, not a big truck.
Yeah, it's a big truck, okay.
Okay. You rotate it? Oh, thank
That
you.
one, perfect.
Mr. Ray's car.
It's not Mr. Ray's car.
This is a four-door. Oh, no, it's not.
Two-door.
Mr. Ray's car.
Okay.
That's our road.
So, well, I'm still recording. We've got the truck is traveling at a constant 29 meters per second.
It's 104.4 kilometers.
Yeah, he's cooking. It approaches the stationary car stop beside the road when the truck is still 106 meters behind the car. So this distance here is 106. The car pulls out in a slow lane with an acceleration of 2.7 meters per second squared. Okay? How long will it take the truck to pass the car? Why are there two possible answers for this? Okay, now, it doesn't matter where you set your zero to be. You can set it to be the truck or the car. If you set it to be the truck, then the car is at plus 106. If you set your zero to be where the car is, then the truck is at minus 106. It's going to work either way. So we're going to set this to 0, and I'm going to set, let's just do this. I will put the car at a position of 106. We all know that the truck passes the car when the positions are the same, right? So the position of the truck is equal to the displacement of the truck because it's starting at 0, right? And the displacement of the truck is equal to, because it's traveling at a constant speed, it's equal to v bar times t. There's no acceleration. It's equal to v bar t. In other words, in this case, 29t. Right? The position of the truck is given by 29t.
You mark that?
Eh?
You can mark that?
Yeah,
What if we did it the other way? Wait, made it minus 106.
that's okay. You can have 29t minus 106. Yeah. Yeah. Now the position of the car, car is going to be equal to 106 plus the displacement of the car, right? D car. Position of the car is equal to 106 plus the displacement of the car. So that's going to be 106. Now, the car is accelerating from rest. So, VIT plus a half AT squared, right? VIT plus 1/2 AT squared. 106 plus 0 VIT, right? Plus 1/2 of the acceleration of 2.7 t squared. So you end up with 106. Half of 2.7 is 1.35? 1.35 t squared. Now we have to set them equal to each other. Passes, something like passes when position truck is equal to position car. So in other words, 29t equals 106 plus 1.35 t squared. Okay? So I've sort of shown here how these two things sort of come together, right? Now I'm just going to write it over to the side here because I know that I've got to be working from left to right. So I'm going to go over here. I'm going to write 1.35 t squared minus 29t plus 106 equals 0. Quadratic formula. Okay, now we can all apply the quadratic formula, I think. I don't need to show that. You should get t is equal to 16.8 and 4.7 seconds. What the heck is going on, Kyler? Why are there two answers? Now, a few years ago, I didn't ask that question. Why are there two answers? I assumed that people would question why there were two answers and start to think about it. Then I had to throw this question in to make it, to sort of give you a little nudge in the right direction. Why are there two answers? Because the truck and the car are at the same position at two times. Okay? Because the truck is traveling along at a constant speed. At some point, it's going to overtake the car, right? But remember, it's moving at a constant speed. The car is doing what? Accelerating. So there's going to be some point when the car does what? Catches up to the truck. Because the car is continuing to accelerate. So there are two times when the car and the truck are in the same spot. One is at 4.7. That's when the truck passes the car, right? 4.7. Truck passes car. 16.8. Car passes truck. Okay? So that's all worth 4 marks. Probably could have been worth more, I suppose. But only people that got it right will agree with that.
I didn't, but I started doing this.
Yeah?
No, you're lying.
Part B says, how far will the car have traveled when the truck passes it? Now you'll notice I even, in questions B and C, I gave you hints to A. Because it says, how far will the car have traveled when the truck passes it? And then in C it says, if the car will maintain its acceleration, how fast would it be traveling when it overtakes the truck? I gave you the answers in B and C. To A, yes I did. Wow, I'm giving you the answer to why there's two possible answers in the questions B and C. You see it now, I'm sure. Okay, so part B. How far will the car have traveled? D equals VIT plus 1/2 AT squared. 0 plus 1/2 of 1.35. My time is my 4.7. And you get 29.8 meters. And then in part C, when it asks you how fast will the car be going when it overtakes the truck, that's a VF equals VI plus AT kind of question.
What the? I find it funny, so why? Why?
Right? The time is, oh, not, what am I doing? The time here for the next one is my 16.8.
I have a question.
45.4.
I have a question.
Uh-huh.
How come when you put the acceleration as 1.25?
Yeah.
Good question. I don't know why. I wrote it. Yeah, that's wrong. Should be 2.7, right? Thanks, Quinn. Yeah. No, because it's speeding up, right?
Yeah, but it's initial velocity is 0, so that means it's change velocity to speed.
What did you say? What formula do you want to use? Oh, I guess, yeah, right.
Yeah.
Yeah. Well, that's basically what this is. It's the same formula.
I got C right.
Yeah.
Okay. Why the hell did
Okay. So, I mean, obviously the hard part is A, but if you showed your work and you got something wrong and then still managed to come up with something for B and C, I certainly tried to work through it and give you some marks as long as your organization was decent.
Wasn't your organization?
It's important, man. You gotta organize it. In fact, we're gonna talk about that real soon, Zach.
You said bad organization.
Yeah, well, we're gonna have a little discussion right away here. I'm all fired up and ready to rock. Looking good, Jory. When you can pass the shake test, that's good. Now, I don't actually think I need to go through 20 or 21. I think for the most part,
I have,
Okay.
How do I know whether, like, I put west, whatever north, how do I know that it's supposed to be
Yeah.
north, something west? Or how do I know which way it's supposed to go?
Okay.
because I usually just put like, because if it was out, it would be, I don't want north.
well, let me just give you the answer first of all. For 20, your resultant should be 243.4, and that's kilometers per hour, and north 8 east. So here's an example here, Zoe, right? North 8 east would have to be north 8 to the east.
Yeah.
Can you draw me what you've got and how you got it wrong so that I can answer your
Well,
question?
like with my answer,
Come and show me. So if you've got your components of, let's just do this. I'm going to move this out of the way. We've got a resultant x of 240.8, and we've got a resultant y of 35.3, right? They're both positive. So it doesn't matter whether you go like this or like that, right? This is your resultant here. Or if you happen to go like this and then like that. It doesn't matter. This time you're going to get, this way you're going to get the north 8 east.
Yeah.
Because you're going to take, -1 opposite over adjacent. You're going to take 240.8 over 35.3. Here, you're going to have it the other way.
So that's what it depends on?
Yeah. So this one is north 8 east. This one is east 82 north.
Okay. So it just depends on.
Yeah. But you wrote west.
Yeah. Okay.
Okay. So yeah, for the most part, number 20 was pretty well done. Number 21, you knew right off the top that you were going to get a subtraction one. I gotta see subtraction. Gotta see subtraction.
I didn't do the works, but they took a mark off her that equal sign, so I'm not good.
Okay, I gotta see subtraction.
You didn't do it.
Why did you start way over here? It's organized, it just started on the side.
But your answer ends up in the top left-hand corner, Zach. Well, on the left-hand side, you circled it over there on the left-hand side.
I could have wrote it at the bottom, I just wanted this big area for you to look at.
I don't want it there. I want it at the bottom. That's where I look.
I circled it. Pretty easy to find.
And then, do I need to go through all of 21?
Yeah.
Okay. An airplane needs to travel 305 kilometers an hour in a direction of north 25 west. If the wind is blowing toward east 14 north at 58, what heading and plane should the pilot take? So we are asking for the plane speed. When you're not asked to find the resultant, if you're finding the plane speed or the wind speed, you need to subtract. You need to subtract. So my resultant is 305. So I want to convert that into components, okay? North 25 west. North 25 west at 305. Now, I encourage you to put arrowheads on there, Cody Arisco, so that your X and your Y's end up going in the correct direction. Okay, so this is resultant X, this is resultant Y. Rx is equal to 305, it's opposite, so 305 sine 25, which is minus 128.9 minus the resultant y is equal to 305 cos 25, which is 276.4. There, that one's positive. Okay, now the wind is blowing at east. It's blowing towards east 14 north. Blowing towards east 14 north. East 14 north. East 14 to the north. This is my wind. This is my wind y. This is my wind x. Put on arrowheads. So wind x. Why do I do the x first? Because I've got the x first here. So wind x is going to be 58, and its cosine 14, which is 56.3. Is that right? Plus 56.3. Wind y is 58 sine 14, which is plus 14. Okay? Now, how do we do vector subtraction?
Subtracting.
Plane x is equal to resultant x minus wind x. Show me the subtraction. Minus 128.9. Subtract 56.3. And you get minus 185. Plane y is equal to resultant y minus wy, or 276.4 subtract 14. 262. Okay, I think you guys can probably combine it from there, can't you? Okay, draw another picture. Minus 185 means left. Y is 262 up. R squared is 185 squared plus 262 squared. R is 321.2. That's your angle right there. That angle there, Zoe, is east something north, right?
Yeah.
Or sorry, west, not east. Right? That's west 54 north. Okay, I threw the last question on there. I liked it, and actually, you guys did fairly well on it. I was
What was it out of?
fairly pleased. It was 1 mark each. I didn't want to make it too much because I was concerned that it was going to be a bomb. But you guys did fairly well. So the motion sensor is on the left end of the track, so the motion to the right is said to be positive. Right? This is negative, this is positive. The cart is a small compressed air cartridge, so the cart accelerates up the ramp for the first 2 seconds. So the first 2 seconds it's accelerating up, right? And then, of course, the next 2 seconds it actually slows down. And, of course, once it gets to the top, then it comes right back down, right? So what does the DT graph look like? Well, for the first 2 seconds, it's got to be speeding up. So it's going to curve up, and then it slows down. So it gets to that. And then on the backwards, does it sort of do that kind of thing again? No, in fact, on this part here, it speeds up, so it should actually be curved like that, right? It hits it, right? But what I needed to see was curved up, curved down, and then curved all the way. That's what I was looking for. That's the DT. Now the VT graph, is there positive and negative velocity? Sure there is, right? It's going up the ramp for the first 2 seconds and increasing in speed, right? And then it decreases in speed down to 0, and then it speeds up negatively, and probably at the same rate. right?
Oh, but
At
then
one
it's the end of
point,
that, it goes straight to zero.
at one point, does the velocity not reach zero?
Right there. Remember, it's a graph of the velocity, right?
Drop hitting zero.
So now the dt is the slope of this. The slope here is positive, the slope here is negative, and this is the same negative slope. So it's pretty straightforward. It's positive, then it becomes negative.
Swastika.
Aztec symbol.
Swastika.
Dude, I thought it was a swastika, and then when we were doing the